Hello, I'm Mark Sponsor, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 19th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a continuation of the calm pattern that's been in play lately. A gale is in the far southeast Pacific, but notice all its fetch is aimed south at Antarctica and nothing aimed north in our direction. The same pretty much goes true for another area of low pressure off the northern tip of New Zealand, and otherwise Antarctic ice pretty far to the north, pretty typical for this time of year. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, that is a dip. It's actually a push to the north in the jet stream in the South Pacific Ocean, and it's in the southern branch of the jet stream. This is the northern branch here. That's not so influential. It's the southern branch where all the action is. So we're looking for a push to the north in the jet stream, sort of like there, but you need a lot more wind pushing up in that direction. That helps create a clockwise flow aloft, and that's the hallmark of low pressure in the southern hemisphere. And that low pressure typically manifests itself down at the surface as well. And if the low is strong enough, it generates winds. If the winds are strong enough, they generate seas. If the seas are large enough, they start radiating away from the fetch area, turning into swell, and swell eventually reaches your beach and produces surf. All right, so we have a trough here. This is the fundamental start of everything, and this is a very weak trough, not really offering any support for gale development. You want at least 110 knot winds. It needs to work the whole way up into the top of the trough and then down a little bit to the side to really do its thing. Mainly what we have here is a ridge, the opposite of trough. Winds pushing south, the Antarctic ice line somewhere about 163, 164 south. So just really there's not much wind energy. Better than last week, but still not much wind energy and not anything good to support gale formation. Put this into motion. We're just looking for any kind of a trough. The thing that sort of was a trough here, you see it getting undercut instantly. It's cut off, doing nothing, and so you just have this flow. I call it a zonal pattern. Winds running flat west to east, but way south, down 70 south, all over Antarctic ice, no exposure to open ocean, offering nothing. We're into Tuesday, more of the same. If anything, this ridge gets reinforced, pushing to the south. You can see it. This is going to be high pressure when we get down to the surface looking at it. Now, a little bit of a trough right here is forecast like Wednesday night. Let's go back a little bit. Yeah, Wednesday, maybe into Thursday, but notice winds. There we go, a little bit of winds. The ice line's like right around here, so only up in here is the only area offering support for gale development. Winds very weak, and then even that trough starts falling south, just not looking good. Big ridge just pushing south over the southeast Pacific. Then we get into Saturday, Sunday, and still just not a whole lot going on at all. And that's it. We're done for the week. So nothing obviously supportive of gale development at the jet stream level. Let's go take a look down at the surface. So here we are, surface level pressure, surface level winds, high pressure right here. What is that, about a 10, can't quite see it. There we go, 1028 millibar high. That's not particularly strong, but you see winds pushing, so just look at the arrows, pushing to the south, pushing to the south. That's exactly the opposite of what we want. We want winds pushing up to the northeast, and at least at 40, preferably 45, well, preferably 65 miles an hour, but yeah, if you're going to dream big, right? Well, that's not happening right now. High pressure, continuing pushing south into Monday, just no support for gale formation. Even another little gale here off of New Zealand on Tuesday, it's falling south, and the winds are all pushing off to the south. You see that? So a penguin storm, nothing more. Now, previous runs of the model, like this morning even, suggested this gale right here. Notice winds pushing to the northeast, but blocked by New Zealand. There we go. A little bit of fetch, 40-knot winds, aimed off to the northeast Wednesday night. But we want to see the low itself move off to the northeast. And we're not seeing that. If anything, it's sort of falling southeast, but a good broad fetch. Now, 30-knot winds aren't going to do it. That'll get you, I don't know, 11-second period swell, something like that. You need 35 to really get to 13-second period. And to survive, for a swell to survive the whole journey to Hawaii or California, you need 40, 45-knot winds. So, yeah, you kind of have it, but it's not pushing north. It's sort of hanging. This actually, in some ways, looks better than what we suspect it's really going to do. Consistently holding, though, into even Friday night before it fades out. So we'll take a look at the wave models, see what they tell us. Anyway, we're getting into Sunday now, and this little gale here is pretty much over ice. And that is, oh, another gale. That just popped up on the charts. A week out, don't believe it, but maybe, beggars can't be choosy, and we'll take anything at this point. All right, let's go take a look at the wave models. So here we go. This is the effect of those winds on the ocean surface. All right, and as you see, a little bit of gale here falling south. That doesn't do us any good. The ice line, 62 north in spots, maybe 65 at the best. And remember, earlier in the season, when we were getting a fair amount of southern Hemis swells, the ice line was down like 5 degrees further south than this. So just a lot more open space to generate storms or generate swell. All right, gale falling south on Tuesday. That doesn't do anything. The new little system forms under New Zealand and generates 26-foot seas, maybe 27, but look, they're already starting to fall this direction instead of up this direction. So broad area of 20, 22, 24, 26-foot seas. Probably Hawaii could get something from this, maybe even California, but size would be pretty minimal, not ideally targeted or aimed. The gun isn't aimed in the right direction. It's aimed pretty much more towards Chile, and maybe we'll give Peru a little bit. Hawaii could get some energy, so could California. We'll see. Keep our eyes on this thing, and there we are, 180 hours out. We know there's a new little system forecast there, but probably the next run of the model, that one will be gone. So then we go looking for wind swell. But before we do that, there is actually some small southern Hemi swell. It's been hitting Hawaii the past couple of days. Nothing huge. I mean, there were some maybe head-high sets, something like that. And something probably a fair bit smaller than that is radiating towards California, expected to hit tomorrow, that's Monday, and sort of peak Tuesday, Wednesday sort of thing. Nothing huge, but something rideable, especially at top exposed spots in Southern California. They could get something at least rideable out of it. Anyway, so moving on, wind swell. At least for California, Northern California, that's been something to look forward to. All right, so we have high pressure, 1032 millibar high. Winds circulate clockwise around the high, generating, and heat low inland. As the high gets closer to the coast, it tightens up the isobars, generating wind that's called a gradient. Now, this is a very weak gradient. It's only producing 20-knot north winds. And yeah, there's some little wind swell in exposed spots in Northern California, but nothing too dramatic. As we get into Monday, that starts fading out. Also notice let's go back a little bit. For Hawaii, the same high pressure system generating fetch, pushing into the Hawaiian Islands, 15-knot trades. That's good for some small wind swell, but nothing dramatic at all. As we get into Monday, the fetch fades even off of Northern California, starts fading for Hawaii, maybe some lingering wind swell. Tuesday, fetch trying to regroup off of Cape Mendocino, but not really doing it, and all but gone for Hawaii. Wednesday, kind of the same thing. Minimal, pretty much when you have this tiny a fetch area and it's only 20-knot winds, you're probably not going to get much, if any, rideable wind swell out of that. Hawaii, really nothing. Thursday, somewhere in here, this thing's supposed to start picking up. We're just looking for it. There we go. Coming Friday, a little bit broader fetch, a little area of 25-knot winds. We'll slide up here. Supposedly some sort of a tropical system pushing towards Hawaii. We'll roll this through so you can watch that. We're on Friday night right now. Saturday. This is actually a downgrade in terms of fetch here. Tropical system. I wouldn't believe a tropical system nearly a week out on the GFS model, but who knows. Fetch, still nothing really for California. As we get into Sunday, more of the same for California. Wind swell for east-facing shores of the Hawaiian Islands for sure. Keep our eyes on that tropical system, and now we're 180 hours out, so nothing really epic. But you know what? This is pretty typical for this time of year, July. Just not a whole lot really good happens. The southern hemisphere kind of takes a break. You get some wind swell, but even that can fade out at times, not do a whole lot. So that's where it is. Probably a good time to go take care of business. All right, let's go take a look long term. What's going on with the Madden Julian oscillation, that periodic weather oscillation that traverses the equator from west to east? When in the active state, it helps feed energy to the jet stream, which in turn helps produce storms or feed storm production. And then, of course, El Nino. When in the El Nino state, everyone knows you get good support in the Pacific Ocean for storm production. And if in La Nina, pretty much the opposite occurs. So we'll dig into that now. So we'll start by looking for signs of the active phase of the MJO. All right, so how do we do that? Well, this is the equatorial Pacific. The MJO is all about things on the equator, and you go, well, how can the equator affect storms in the north or in the south? And the reality is it has a very significant impact. All right, so this is the East Pacific here. This is the West Pacific here. This is data from the TAAO buoy array, series of buoys strung across the equator used for monitoring El Nino. But there are wind sensors on those buoys. Now, this isn't like real-time wind feeds. It's 5-day average winds, but that gives us a good idea what's going on relative to the MJO. So winds are out of the east. Trade winds pretty strong over the East Pacific, Central Pacific, then a little bit weaker in the West Pacific, this place we call the Kelvin wave generation area. That is, when the active phase of the MJO moves over the West Pacific, like here, and just 5 degrees north and south of the equator from 135 east to about 170 west. When the active phase moves over here, it stomps on the trade winds. The active phase acts like low pressure. It suppresses the trade winds and then allows warm water. See these reds here? That's water temperature to start sloshing to the east, but not on the surface. Underneath the equator, a big ball of warm water that takes 3 months to make it from the Kelvin wave generation area over to Ecuador, and then it erupts along the coast here if it's strong enough and has enough momentum. If you get successive Kelvin waves driven by successive strong active phases of the MJO, that can help kick off El Nino. All right, well, right now, we don't see that happening. We see easterly trades the whole way across, though pretty weaker than they've been in the Kelvin wave generation area. But it's not just the actual winds, it's the anomalies, the difference from normal for this time of year. Because sometimes the year, like now, the trades just nuke and they blow hard all the time out of the east. So even though it's easterly, here you look at the anomalies and they're pretty much normal. If there was a big arrow pointed from east to west, then that'd say they're stronger than normal, but they're pretty much normal. A little bit stronger than normal over the Central Pacific, and a little bit stronger, you see these couple extra arrows here, over the East Pacific. So, no real sign of the active phase of the MJO. You'd want to see suppressed trades here. We're not seeing, or the arrows coming out of the west, if anything. All right, so what's the forecast? All right, now this is a strange-looking chart. This is the whole planet on one page, right? Not just the Pacific Ocean. But you can easily tease out where the Pacific Ocean is. It starts, and this is on the equator. This is zonal wind anomalies 5 degrees north and south of the equator. Perfect for what we're trying to do here. So 135 east, that's the beginning of the Pacific there, to 170 west. That's the Kelvin wave generation area. And then on the equator, it goes the whole way to Ecuador, so that'd be about 80 west, somewhere like right there. So the Pacific starts there and ends, there. And you can see this blue. Blue is easterly anomalies. So this is what's been happening the past month. You can see blues everywhere. Easterly anomalies, stronger than normal out of the east, inactive phase of the MJO at a bare minimum. And if it keeps that up for a long period of time, then that would suggest La Nina. And we've been talking a fair amount about the possible development of La Nina. All right, and so for the next week, what's the forecast? Well, you can see it pretty simple. East anomalies continuing stronger than normal and quite strong on the date line the last 2 days of the model run. All this suggests the inactive phase of the MJO. Let's keep digging. All right, so our goal here is we're looking for the active phase of the MJO, hopefully, because the active phase feeds energy to the jet stream, which feeds storm development. All right, so what are we looking at here? Outgoing long wave radiation. Where is that? OLR. There it is, right there. Outgoing long wave radiation. Sorry, I got to put my head around the camera here. Anyway, all right, so the yellows suggest more sunlight reflectivity than normal, meaning high pressure, meaning the inactive phase of the MJO, and the blues, the active phase, less sunlight reflectivity, negative anomalies. All right, so what we have, and South America, Central America there, the equator running right across here. Kelvin wave generation area right over here, and there's New Guinea, the Philippines, so right in this area, 5 degrees north and south of the equator. The yellow, meaning the inactive phase of the MJO. That doesn't help us, but not very strong. And this is from the statistic model. Same deal, 5 days out, weakening, and dead neutral 15 days, about 2 weeks from now. Now, the dynamic model, not so forgiving. Inactive phase, if anything, building more 10 days out and still holding, so no signs of the active phase. If anything, continued likely easterly anomalies and the inactive phase of the MJO. So no obvious support for storm production. Phase diagrams, another way of looking at the MJO. So assume how do you read this thing? Look at the circle here. Assume you're looking down on the North Pole. When you're looking at the circle, you're looking right down on the top of the North Pole, and the MJO travels from west to east around the chart on the equator, from the Indian Ocean, over the maritime continent, that's like Bali, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, and back to the Indian Ocean. The active phase and the inactive phase is 180 degrees or on the other side of the planet. So this chart shows you where the active phase is. The heavy dot is where it is, smack in the middle of the Indian Ocean. Now, the further the dot moves away from the circle, the stronger it is. So an exceedingly weak active phase of the MJO, and its forecast is to limp off to, I'll say, the maritime continent, Bali, somewhere like that, and still be exceedingly weak 2 weeks from now. That, according to the statistic model. The dynamic model, the GEFS, says basically the same thing. Maybe it being a hair bit stronger in the west and more towards the West Pacific, but still very weak. So this has been the problem for months now. The MJO is all but non-existent. It's just dead. It doesn't wake up. It's not doing anything for us. And so the storm track has a real hard time getting organized. The jet stream, you saw the jet stream charts. It's displaced to the south. There's no energy in it at all. It's stronger this week than it was last week, but still just very weak. That's all tied to this MJO thing, with the MJO being collapsed. And we think that's all tied to the ENSO cycle, the El Nino-La Nina cycle. But more about that in a minute. All right, the upper level model. So this shows you the propensity for precipitation. Greens are favorable for precipitation, oranges and reds not favorable. So you could read the greens as being the active phase of the MJO, the oranges the inactive phase. So today, and this is in 5-day increments, that's South America there, Central America, the equator right there, New Guinea, the Philippines, right? And Kelvin wave generation area right there. So you just keep looking, it's the same image over and over and over, or at least the same background map with the MJO moving over top of it. All right, so you see the inactive phase of the MJO moving into Central America, some weak pulse of, I'll call it the active phase of the MJO in the southeast Pacific, or in the East Pacific, and then a inactive phase building in the West Pacific. For the next this little active phase. Probably it's already out of the Kelvin wave generation area. It's not going to do anything here other than maybe support some tropical development. That's probably why the models are picking up on some tropical storm development east of Hawaii. And by the 29th or maybe August 3rd, that's supposed to be inland, inactive phase, in control of the Kelvin wave generation area, continuing pretty much all late July into, we'll say, mid-August. And then, theoretically, a weak active phase develops. Notice it's weak over here, and then as it moves east, it builds into late August. So again, this sort of suggests that, if anything, July's a write-off, and it's somewhere, we'll say, later in August, according to this, that maybe we could get some storm development. That's the sweet spot for the summer, it looks like, right now, according to this model. And then the 1 month model, this is the CFS model. CFS, this is 850 millibar winds. This is a east-west component of the wind, up at about 4,700 feet. A good proxy for what's going on at the surface. Same sort of story. Here is the Kelvin wave generation area from 135 east, draw a line right up there to about 170 west. You can see right here, easterly anomalies have been in control. I mean, the last of what sort of looked like a normal pattern ended about the end of May. You can see the blues started to fill the Kelvin wave generation area, and our forecast to continue to fill it the whole way through mid-August. And with this purple line here, where's the key? That's the low-pass filter. That shows a dotted line suggests high pressure in control. This would be the active phase of the MJO here, but not even making it. It's in the Indian Ocean, locked there. No MJO signal at all in the Pacific. And for the forecast for the next month, east anomalies in control. Pretty much this inactive phase of the MJO going nonstop. And it started, according to this, in June, this easterly wind pattern, and no end in sight. That's very much a sign of La Nina. And then finally, the 3-month outlook. Now, this is that same sort of chart. Kelvin wave generation area starts right here, goes to 170 west, but the Pacific ends over here at like 8. You can actually see the seam right here. This is where the East Pacific, Equatorial Pacific ends. It starts right around in here. And now this is past performance here, and you can see this, no real MJO signal, no real westerly wind events at all since even April, and a fair preponderance of blues. Those are easterly anomalies. And then as you look forward in the forecast, you just see this death blue taking control, little bits of westerly anomalies trying to form, but just this is what La Nina looks like in our estimation. Let's overlay the MJO. Now here's where things get even more interesting. Okay, so we have blues, and this dotted contour is the inactive phase of the MJO. So yeah, it'd be typical to see easterly anomalies during an inactive phase of the MJO. But then you see this 1, 2, 3, 4 contour active phase of the MJO forecast to set up, we'll say mid-August and continuing into late September. But even at that, you have westerly anomalies. They're not particularly strong. They die. Well, they've made a little more progress. They make it to 170 east, not even quite to the date line. And then east anomalies are forecast over the entirety of the Pacific Ocean starting August 4th and continuing pretty much nonstop from there. All right, inactive phase follows behind that. Model doesn't have a good handle on it, just shows sort of a mixed pattern, but I'd be willing to bet you're going to see easterly anomalies developing, if anything. So, and then finally, the low-pass filter. What is driving all this? Well, low-pass filter tells the story, just like it did on the other chart. This dotted line here, high-pressure bias. In fact, we could take the MJO out and the wind out, and you can just see it like that. So here is high pressure is building over 180 west. That's the date line right now on the equator. Forecast to build and grow in coverage, growing the whole way to the California coast and even past there as we get into September and early October to 2 contour lines. And then notice last winter, low pressure, the solid contour is low pressure bias that was in the Pacific, is switching and moving into the Indian Ocean. That is the typical La Nina setup. High pressure here, low pressure there, versus El Nino, where you have low pressure in the Pacific and high pressure in the Indian Ocean. So pretty much yet more data suggesting that we're moving towards a La Nina regime, at least based on what this model and some of the models are suggesting. So we mentioned something about the strength of the MJO, just for fun. So back in 2013, so this is a chart. It doesn't show you where the MJO is. It just shows you how strong it is when it turns active. And typically when people say the MJO, they're talking about the active phase of the MJO. But you can see active phase and inactive phase. It's not a perfect chart. So back in 2013, and this is the relative strength. One's 2 standard deviations, 3, etc., etc. So kind of a middling, normal kind of MJO. And then in 2014, the MJO started collapsing. 2015, we were in a major El Nino, big massive spikes of the active phase of the MJO, continuing even into the fall, even into January and February of 2016. Then it started moderating. 2017, one big pulse of the active phase of the MJO, and then it just died completely. Then 2018, boom, the MJO kind of woke up. You get the idea here. And then 2019, weak. We had a little pulse in February, and then very, very historically weak active phase of the MJO this year. All right, so the MJO is not the whole sum of everything. It is one component of the weather cycle. The ocean, it's the interaction of the ocean and the atmosphere that create El Nino, La Nina, the active phase, the inactive phase. So, or the strength of the active and inactive phase. All right, so what are we looking at here? The ocean, subsurface, not on the surface, down deep. This is the West Pacific here, East Pacific here. Again, data from the TAO buoy array, that series of buoys strung across the equator. These are the anchor lines on the buoy. The X's are the sensors. They collect data. They beam it up to the satellite. Satellite radios or transfers the data to somewhere over on the northeast coast, I think Maryland, somewhere like that. They go process all the data and then use a model to connect the temperatures where there are not sensors. And what you end up with is kind of, you see warm temperatures, 29 degrees, that's centigrade, okay? In the far west Pacific, it's about where it was last week. 28-degree isotherm at 160 west, that's about where it was. Now the 24-degree isotherm, it's actually made some pretty good progress. It had backed off a fair amount. It's now at about 115 west. So this sort of suggests, just looking at this, that the ocean, the models are saying we're in La Nina, but the ocean maybe isn't quite there yet. In fact, anomalies, differences from normal from this time of year. I mean, a month ago, big, massive cold pool right here. We thought, oh man, you just look like we're heading right for La Nina. And now we don't have Kelvin waves, but we have this sort of generalized weak warm pattern almost filling the Pacific. That said, there is this pool. Now again, this is a model. This isn't quite, this is not a guaranteed thing, but this -1, -2 degree. This is what happened before. We started getting this little pocket of cool water a couple of months ago, and the further east it went, the colder it got, the deeper it got, and it erupted to the surface, and boom, just like shut down the ENSO cycle, just crashed the jet stream. Cold water does not do good for storm production. It's stable. If anything, what builds on top of cold water is high pressure, and high pressure does not support storm production. So, warm water, because it's warmer than normal, evaporates, causes evaporation. That causes the pressure to lower as warm air rises, and that's what feeds storm production. And of course, you got to have precipitation to create storms. All right, so right now we're looking kind of neutral for the moment, though this pocket is troubling. But this is just one model's view of the world. Then there's this other model here, called the high-res model, because it seems to be, it's a little bit, runs behind the other model about a week, but seems to have a better handle on things sometime. It shows the big cool pool still lingering in the East Pacific, and here's the new cool pool developing. It almost, typically, this is where you'd see warm water and Kelvin waves going down like this, driven by westerly anomalies in the West Pacific, pushing under the equator a whole way to the East Pacific. Instead, now what we have is like an anti-Kelvin wave cycle, a cold water Kelvin wave cycle. So at least that's what it appears. All right, and you can see that maybe a little bit better here. So this is a historical view, all right? This is the West Pacific here. This is the East Pacific here. This is a year ago. When was that? August, something like that. Kelvin wave created warm water, started pushing under the equator. A stronger Kelvin wave here in September of last year made it the whole way across the Pacific, kind of giving us some hope for the winter, though we really didn't have it. And then November, December, another Kelvin wave, but they didn't quite make it either. Then here is that April, that big cool pool that showed up subsurface, made it the whole way across the Pacific. And we think right now, back here, there's a new cool pool starting to build. You see all this warm water building here. You go, hey, this looks good. This looks interesting. Well, this is sort of the make or break moment. Is this warm water going to win the day, or is a new cool pool like an anti-Kelvin wave going to develop and take over? That is the unknown right now. The model, the CFS model, very strong, saying fully, yes, we're moving towards a cold regime. Some of the other models sort of going, maybe not. Maybe it's just going to be neutral. So that's the unknown. Just one more view over time. This is the upper ocean heat anomalies at the top 300 meters of the ocean surface. Just shows you whether the balance of energy in the ocean from the date line over to 100 west, this is near the official El Nino monitoring region. Is it warmer than normal? You can see in October it was, and it continued warmer into March. And then we had that big massive crash that happened May, June, July. And we think, well, we're over it, but is it going to start again? We just don't know. That is the big unknown, and that is, what we're looking for day after day. How is this going to play out? It's sort of like a soap opera, right? You never know how the plot's going to twist and turn, and, we have all our models, we have all our sensors, we have all this great technology, but at the end of the day, the atmosphere is going to do what it wants to do. We think we have a handle on it, but you never quite know for sure. So we talked subsurface. Let's go take a look at the surface. And it's pretty obvious what's going here. So this is the equator. This is 4 panes that make up basically the same image. But basically you see cool water off of Chile, Peru, then radiating off Ecuador over the Galapagos the whole way out. The blues are colder than normal, the yellows warmer than normal. It's only on the equator 5 degrees north and south of the equator that we're worried about. This is in what they call the Nino 1.2 region, this area right off Peru. The official El Nino monitoring region starts at 120 west, so right here out to 170 west, so somewhere over here. And you can see cool but not freezing cold water through the heart of the official El Nino monitoring region. The trend for the past 7 days, is it getting warmer or cooler than normal? And this is the only area we're interested in, right here on the equator. That's South America, Central America there, New Guinea, Kelvin wave generation area over here. But what you see, the blues are colder than normal, or the trend is getting colder, and then you see this getting warmer. So it's kind of a mixed bag. It was actually in favor of cooling last week. Now it's sort of in favor of warming. So this guy down here, he's not getting any colder. If anything, maybe he's losing a little bit of ground, and that's exactly what we want to see. And the closer we get to fall, the more we want to see warming here, because if the water is warm here, that helps push the jet stream into the U.S., that helps bring storms into the Gulf of Alaska, that helps bring moisture into California, that feeds snowfall in the Sierra, so it brings a whole host of good things for us. But when you have cold water building here, like we said before, that sets up high pressure north and south, so that would be up here in the Gulf of Alaska, down in the southeast Pacific, and that sort of shuts down the winter storm cycle. Here's the backed off view. You can see generally cooler water over the equatorial Pacific. Is this enough to declare La Nina? Well, let's have that discussion. Sea surface temperatures in the Nino 1.2 region. This is the area right off of Ecuador over by the Galapagos, the far east equatorial Pacific. You can see back in April, they were pretty much normal, third of a degree above normal. The trend has been steadily downward. 4 days ago, we were 2 degrees below normal. Okay? This is not, though, the official El Nino monitoring region. This is that area further to the west, north. So, let me try it this way. To me, this is the rainfall indicator for California. And when you see colder, 2 degree below normal temperatures, and they're holding for months, if it continues like that into August, September, then we will have a very dry winter. That doesn't mean that there won't be snow. It'll just be a lot further north. High pressure will rule off of California, driving the jet stream further north, up into Oregon or Washington or even British Columbia. All right, the official El Nino monitoring region, the Nino 3.4 region, more out towards the central Pacific, 120 west, that's south of California, out to 170 west, that's almost out to the dateline. Temperatures right there today, minus 0.019, so dead even. They've been a little bit above normal the past week or so, but they were down to almost a little bit beyond half a degree below normal back in May. But what this suggests is La Nina is trying to organize. It's cold near Peru and Central America, but it's not strong enough, doesn't have enough momentum. It's not translating into the Nino 3.4 region as one would expect. We're going to get into that in just a second. So we talked about the MJO component of the ENSO cycle. Then we talked about subsurface temperatures. We talked about surface temperatures. Now we're going to talk about, and we talked about the atmosphere above a little bit, but then we're going to go one step further. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When pressure is lower than normal at Tahiti, the index turns negative, sort of like right there and there and there. But when pressure is higher over Tahiti than Darwin, the index turns positive, like that. Today's value, minus 1.79, so pretty much neutral. Neither El Nino or La Nina or the active phase or the inactive phase. The inactive and active phase of the MJO affect this tremendously. All right, so, and we kind of go back in time and look, yeah, we were a little bit negative there. We were positive a whole bunch. We've been probably more positive than we've been negative. So the 30-day average attempts to get the noise out of the numbers. What's it saying? Today we're at 0.8. Okay, so what's that? That's barely positive, but yesterday we were at 0.21. The trend, now you see we were down at minus 0.8 a month ago. The trend is steadily rising. That's towards La Nina, towards the inactive phase of the MJO. The 90-day average takes even more noise out of it. Where were we a month ago? Minus 3.31. Where are we today? Minus 1.4. So we're still biased towards El Nino. We're not even to neutral yet. This is generally in the neutral territory. We're not anywhere near the La Nina range according to this index. And that brings us to the forecast for sea surface temperatures in the Nino 3.4 region, the official El Nino monitoring region. Here we are, almost the end of July, so that'd be right here. Our temperatures are effectively dead neutral in the ocean. This model's saying we're supposed to be half a degree, hang on there we go, so you can see it right there, half a degree below normal, and we're not there. And the trends, and it's been showing this just precipitous off the cliff drop, and it hasn't happened, and it hasn't happened, and we're beginning, yes, there is cold water, but not in the Nino 3.4 region. It's all over in the Nino 1.2 region. Now, that's not saying that it's not going to be like an El Nino winter. I mean, effectively for California, unless some miracle happens, you can already see it's going to be drier than normal. Storm production, just given what you're seeing this summer, weak, the jet stream's completely fallen apart. There are things that are happening in the atmosphere. That's why we go to all this detail. There's things happening in the atmosphere that all the indices and all the models and all that stuff don't get a full grip on. They do a good job. They give you teases. They give you indications. But right now, it's looking like La Nina in the atmosphere based on, the water temperatures and things like that. This model says strong La Nina dropping down to 1.1 degrees below normal in, the fall time frame. To me, the longer this start of this precipitous drop delays, the more likely that this deep trough isn't going to happen this winter. Now, What's all this all mean? Well, we're watching this ball of cool water trying to develop in the West Pacific subsurface, right? Okay. And based on the previous ball, we'll call it an anti-Kelvin wave, whatever you want to call it, by the time it reached Ecuador, it was freezing cold, and it just dropped the bottom out of surface temperatures in the East Pacific. If this next one does it, then maybe we will see something, maybe not. So this tends to overstate it, too, by about 50%. So maybe half to 0.6 or 0.7 of a degree in the fall time frame is possible, but all that depends on this cool subsurface ball of water that we're monitoring that's trying to take shape, just somewhere under the dateline, a little bit east of the dateline. So that's going to be the story. That's what we're going to watch for the next couple of weeks. If that happens, then, we don't think it's going to be doom and gloom like this. Maybe we'll be into some light flavor of La Nina. But if it really turns robust and somehow does some miracle, maybe we'll be down here. But I think that at this point in time, we're beginning to think this is a bit overstated. Still, that said, we've had cold water for months now in the East Pacific. We don't think that's going to change. Even if this anti-Kelvin wave, whatever you want to call it, develops weaker than normal, it's still going to feed cool water. That's still going to build high pressure in the Gulf of Alaska. All the signs are there already. I mean, the southern hemisphere is, in terms of storm production, is just, we had one big storm and a couple of weak ones, but other than that, been pretty lackluster. Wind swell, north wind, another sign. Northwest winds nonstop in the Pacific off of Northern California just means high pressure is strong and in control, and that's the setup for La Nina as well. So, anyway, that's kind of it. That said, there is small southern hemi swell coming. Going to arrive in California tomorrow. Next couple of days, something to ride, nothing special. After that, maybe one really tiny little system forecast off of New Zealand, but that's still a couple of days away from even developing before it even becomes real on the models. So we'll watch that. Beyond that, we think La Nina, some flavor of it, even if it isn't officially declared La Nina, the die's already set, the jet stream, the ocean, everything is the strength of the MJO. We saw that earlier on the charts, just very weak. That's all classic La Nina kind of symptoms where, there's just no active phase of the MJO, nothing really to drive anything. And we're kind of due. We've been in a warm regime for a couple of years now, so it wouldn't be surprising to get a weak kind of La Nina. Get that out of the system, and then maybe next year and the year after that, things will return. So, you got to pay at some point. It's probably our time to pay. With the virus out there and everything else, and some people not being able to surf as much as they'd like to, hey, maybe it's a blessing in disguise. So stay safe, take care of yourself, surf when you can, be smart about it, don't do stupid stuff, be healthy. We want to see you back next week when we do this. If you've enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. You know how to do it. Hit the subscribe button, hit the bell. We'll give you notifications when we do this. If you don't want to do that, it's certainly your prerogative. You can always go to stormsurf.com. All the data is there that we showed you tonight. And links to the video can be found there as well up at the top of the page. All right, so that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.